In 1986, two internationally reputed Canadian organizations, the Atomic Energy of Canada Limited, AECL, and l'Institut Armand Frappier, IAF, combined their resources to develop and promote Canada's radiation processing technology and its diverse applications. The Canadian Irradiation Centre, CIC, was jointly founded in order to combine the expertise of the AECL and Crescella, the latter being the only one of the IAF centres specializing in applied food research. Created 50 years ago, the IAF is a university complex located in the city of Laval, Quebec, on a large campus of 57 hectares. The IAF is renowned worldwide for its contributions to improving public health. It is subdivided into 6 research centers: immunology, virology, applied microbiology, epidemiology, comparative medicine or veterinary medicine, and applied food sciences. The IAF has 4 objectives: research, teaching, services, and production. Since its founding in 1972, Crescella has directed its efforts towards research on industry's needs and problems. Through its work, Crescella contributes to the development of the biofood sector. The AECL has been a crown corporation of the Government of Canada since 1952. AECL has gained international acclaim for its contributions to the technology of isotopes and its applications in medicine and industry. The AECL dominates world markets. Their products are exported to more than 100 countries. The CIC was inaugurated in May 1987. Its objectives are research, development, teaching, training, and demonstration. Inasmuch as the CIC favors collaboration, Crescella researchers adopt a multidisciplinary approach focusing on the establishment of norms and the procedures of irradiation treatment. Crescella and the other IAF centers integrate their activities with those of the CIC. The CIC has an industrial-sized gamma irradiator and is well equipped with laboratories which facilitate research in chemistry, microbiology, nutrition, food sciences, sensorial analysis, dosimetry, and plant physiology. The biochemistry and analytical chemistry laboratories are equipped with very sophisticated chromatography, spectrophotometry, and mass spectrometry analysis instruments. These instruments identify and quantify products such as proteins, amino acids, sugars, lipids, minerals, vitamins, and enzymes. At the CIC, the chemistry research is oriented towards the effect of irradiation on the organic chlorinated compound residues such as PCB and certain insecticides. All foods may contain microorganisms, their number and species greatly varying according to the nature of the food product. The microbiology laboratory is involved in determining the doses of irradiation required to eliminate pathogenic organisms and those responsible for food spoilage. This prolongs shelf life, reduces food loss, and supplies consumers with a wide choice of foods. The elimination of pathogenic microorganisms improves the wholesomeness of food and greatly contributes to the reduction of food-related diseases, not only in Canada, but on a worldwide scale. The studies in the Food Science and Technology Laboratory concentrate on the effect of irradiation on the physical and nutritional qualities of foods. Applying irradiation to plant physiology can accelerate plant growth and reduce seed infection and infestation. The improvement of agricultural and forestry plants is a major research interest of the CIC. Its approach favors the use of in vitro culture for the micropropagation of superior plant species and for the production of new genotypes through the fusion of protoplasts. Equally, the CIC is involved in molecular biology with respect to the genetic engineering of plant life. The prevention and detection of plant pathologies are other aspects of its program. In dosimetry, methods are developed to determine the amount of energy absorbed by a specific product. Many types of dosimeters are used: chemical, organic, and semiconductor. These systems are carefully verified and compared with each other in order to determine their effectiveness and to establish a worldwide standardization of these methods. Significant amounts of fish and meat are still not being used as food, and the irradiation opens the way for the creation of new food products for animals and human beings. The CIC can determine the irradiation doses needed to rid these potential foods of contaminants in order to make them useful for the food industry. Irradiation is not only food-related, it's also used worldwide in the medical field as a method of sterilization. By associating ozonization and irradiation, the CIC continues its research on the treatment of potable water, reducing to a minimum the need for the addition of chemical products. The World Health Organization is concerned with the number of diseases transmitted by contaminated waters. With the collaboration of researchers in concerned countries, the CIC is planning to create water treatment plants to serve communities worldwide. The chemical application of irradiation in the fields of plastic modification, wood byproducts, cosmetics, and pharmaceutical products is another of the CIC's projects. In the 1970s, a United Nations Committee of Experts on Food Irradiation coordinated research and evaluated the results on an international scale, establishing the wholesomeness of irradiated foods. In 1983, the Alimentarius Codex Commission of the United Nations declared that the irradiation of food up to an overall average dose of 10 kilograms presents no toxicological hazard and introduces no special nutritional or microbiological problems. However, the use of food irradiation is still a controversial topic. Consumers are questioning whether this technique is safe and the nutritional value of irradiated food. The CIC is open to the public and industry in order to demonstrate the safety and significance of the application of this process. Scientists, professionals, technicians, and others come from every part of the world to undergo training at the CIC, the only North American training center for food irradiation processing. Because of the AECL's expertise, concerned industries can rely on technical training by registering their personnel in a 3-week program that will teach them how to safely operate an irradiation center. A 1-week training course is also given so that they may stay informed of the latest technological developments in this field. The center will also admit students to doctoral and master's studies and to postdoctoral research. A 450-hour program leading to a university graduate diploma is being offered to professionals by the IAF. The CIC is also structuring a training program in this field which is expected to be sanctioned by the United Nations. Such a program does not exist anywhere else in the world. The recent international approval of food irradiation processing has greatly awakened the interest of concerned nations regarding the quantity and the quality of their food production. Food irradiation will soon become a means of preventing several diseases and of extending the shelf life of food.
I had the honor in 1948 of attending the first World Health Organization meeting in Geneva as a technical delegate of our country, Canada. The main problem were concerning contagious infection such as malaria, tuberculosis. If I refer to the present situation, 40 years later, there were some solutions found about the first new vaccine. Vaccines against poliomyelitis, against influenza, and antiviral vaccines. We can foresee another kind of diseases which we call in medicine chronic diseases, diseases of the kidney and the heart. And in that special case, we have a problem which is the early diagnostic. In conclusion, I might tell you a citation from Goethe, the poet. You should regain the heritage which you received from your parents, without what it would not pertain to you truly.
Well, you just finished the visit of the Canadian Irradiation Center facilities situated on our beautiful campus at Institut Armand Frappier. What you have seen is the best equipment and also a very young and active team at the service now of the population and through the use of a new high technology that makes this facility unique in the world. Now we can address ourselves to research, development, training, and demonstration of the Canadian technology. We are now pleased to see that the Canadian government has, at the beginning of June 1988, accepted irradiation as a process and no more like an additive. This will allow us to form people now to the application of this technology in line with better health and better enjoyment of life for the population. It will allow us also to help the developing countries economically to export some food that we need and exchange in turn with some products that they cannot produce in their country. So there's a great future for this new technology, and we're proud that Canada is recognizing its value, and we will work hard to convince the population, educate the population to the innocuity of the process and the wholesomeness of the food that is irradiated. On the eve, on threshold of the year 2000 and beyond. And this is what we're addressing ourselves to in here, and we're happy that you have visited with us.